Today's lesson is fractions and decimals. Our goal is that we can write fractions as decimals and order them from least to greatest. Vocabulary. A terminating decimal is when the quotient of a long division problem has a remainder of 0. The decimal terminates or ends. As always, remember to pause, rewind as necessary. I'm going to keep moving. Examples. 4 and 5/10, that terminates. It ends after the 5/10. 2 and 75/100. 8 and 7,831 10,000ths. All right, so those are all examples of terminating decimals. Repeating decimals, when one or more digits repeat without end. So here we have 2 and 3 repeats, 87/100ths, or 87 and 25/100ths where the 25/100ths repeats, and 8 and 765,000ths where 765 is repeating. Okay. How to convert a fraction to a decimal. What operation does the fraction bar tell you to do? Hopefully you know that it's divide. Therefore, you divide the number by the denominator in a fraction, and the result will be a decimal. I'll say that again. You divide the numerator by the denominator, and you're going to get a decimal. You will have to do this on a calculator, or I'm sorry, without a calculator on a unit test. So you're going to have to be able to do long division on this assessment. So our first question is, our first example is to convert 7/20 into a decimal. So we're going to divide 7 by 20. So think of it like that. 7. All right. So if we look at that, how many 20s? Hopefully you remember learning. We kind of imagine it without that decimal there. Okay. So how many 20s are inside 70? Hopefully you look at that and think 3. So I multiply, I get 60. I subtract, I have 10 left over. So I'm going to put another 0 here so I can bring it down as a placeholder. How many 20s are in 100? Extend my line here. Lining up is really important here. So I do 5 times 20, I get 100. I subtract, I get 0. So I have remainder of 0. So 7/20 is equal to 35/100ths. Now the 0 in front of there does not really matter. You can put it there, you can leave it off. It doesn't really matter. It's a placeholder. Moving on. Let's do a little bit at a time so we don't overwhelm ourselves. Okay, so we're going to convert, dollar in hand, okay. Convert 5 and 2/9 into a decimal. We're going to set up the whole number part of the mixed number to the left of the decimal point. So, what this looks like is we're going to have 5 and something to fill in there, okay? Now, we need to convert the fraction part into a decimal. So, we've got 2 divided by 9. We're going to just throw some zeros there and see if we need them all. We may not need them all, but let's see. How many 9s are in 20? Well, hopefully you look at that and you think, okay, there's going to be 2. Again, we're ignoring that decimal there for the sake of our division. 2 times 9 is 18. Oh, look at that. I've got the same problem again. What kind of thing are we noticing here? I've got an 18 again. Well, I see that I have a repeating decimal. So, I have 5 and 2/10 repeating. Okay? All right. We've got an or we convert the number into an improper fraction and to divide the numerator by the denominator. So the other way we can do this is we do 5 times 9 plus 2, and all of that will go over the 9. So 5 times 9 is 45 plus 2, so we've got 47 over 9. So now, I come down here, and I actually have to extend this. 47 divided by 9. 47 divided by 9. Again, I can put those zeros there for my placeholder. How many 9s are in 47? There are 5. Imagine that. I multiply this out. I subtract. 47 minus 5 is 2. Oops, I don't need that 0. Or that decimal. Okay, so now how many 9s are in 20? 2. I multiply, I get 18. I subtract, I get 2. Huh, look at that. I still have a repeating thing. So, I forgot to put my 2 up there for the second one. All right, you get the point. So I still get 5, and the 2's repeating. Okay? All right. Hopefully, at some point, you learned bar notation for repeating decimals, where we put 5 and 2/10 like that, with the bar over it for a repeating decimal. That is acceptable notation, unless you're told to terminate it at some point, to round it at some point. Okay, so now our goal is to order these rational numbers from least to greatest. So we've got to figure out which is least to greatest. Okay, so we have to think about these. This is 5 divided by 2. So that's going to be 2 1/2. So we know that's our last one. 2 divided by 7. I didn't give myself much room there. Can I move that all down? I can. All right. So that's 2, 14, 6, 8. Okay, so that gives us an idea of where it is 0.28 something, right? 0.28 ... We don't, I don't show you the ... but that's an approximation, right? So that gives us that, okay? Because that would give us this, right? We could keep going, but we don't need to. We just need to figure out about where that goes. So our first number here is going to be the 2/10. And we always use the numbers as they appear in our list. So we use that one. And I always cross them off because it lets me know that I used that number and you don't forget anything. Then we've got the 2, because this is 0.20, right? And then we've got 0.2 repeating. So then we've got that next. Okay. And then the 25/100. So we got those 2. Then we've got 2/7. And then we've got 5/2. All right? Hopefully that works for you. And as always, I hope you're pausing this and doing yourself before you're just jumping in and watching me. Okay, so 8. How many 3s are in 8? It's greater than 2, right? So we've got 2 plus something, 2 point something. Well, but this one's 2 point something, so that's 9 divided by 4 is 2 1/4. And this is going to be 2 2/3. So, okay. So we know those two are last. 2 2/3 is 2/3 is more than 1/4, right? Okay, so we've got those two last. And then 4/9, that's less than 1/2. So that's going to be our first one. And then this is 1.90, and this is 1.94. So we got 1.90 and 1.94. Okay, so there we are. We've got that one and we've got that one, and we used them all. Okay, hopefully you got this. If you have questions about it, please bring them to class and ask me next time you see me. Until next time.